Okay, so in this video we are going to take this a step further by now determining the resultant force of these two forces inclined like that one. We said we're going to use the parallelogram rule if you've watched my previous video. So how does this thing work, parallelogram rule? Now you see you are given a force is applied into this body going to this direction and the other one to that direction. Okay, if you are good at imagining, you will know that the net direction, the resultant, this thing will just move into this direction. Okay, yeah, it will move into that direction. For we're gonna see why it works now. Okay, it's not necessary for it to be exactly in the middle, right? What if this force here, this person is way stronger, is applying much more force, so this will be a bit slanted into this direction more than this direction, because this component will have much more influence on the resultant force, making this go much into this direction rather than this direction, right? But at the end of the day, we know the resultant, it's like that one. So how do we know exactly? Because we know these forces will never be the same, they'll be slightly different or much more different. How do we know exactly the amount of this force, the magnitude of this force? That's why I said use the parallelogram rule. That means we complete this parallelogram, right? This one we complete it here, okay, and this one we relate it here. So we find this length, we find the angles using the parallelogram rule, right? We have this amount here, it's FE, this is FD, this FD, and this is the same as FD. Let me these ones, and this is FE. Okay, so we'll use the appropriate, if you're given maybe this whole angle here, maybe you are normally given this whole angle as theta, so maybe you can find the angle here, which is the same, is going to be theta according to the rules of geometry. Then you can find again the angles here by taking 360 divided by minus these two, and then divide by 2, you'll get the angles of this place and this place as alpha and alpha, let's say. So that means you can then find the values. Again, before you start solving these questions on parallelogram rule, you should understand that this parallelogram rule always works. And do you know why it always works? Because if you pay attention, for instance, if you just geometrically draw them, the longer the side, that means if maybe FE, this force is very small, right? Maybe small compared to FD, right? That means geometrically, maybe I scale it, I draw maybe a small value of FE here, right? I draw a small value of FE. The same diagram, I'm just trying to replicate it now trying to be more realistic, and FD is large, right? And FD is large, maybe like that one. These are forces. I'm trying to, the longer the side, that means the force is stronger than this one, right? Here I said if this force is stronger, the resultant will somehow shift towards this one, because it's applying more force, then the resultant will lean towards the person applying more force, right? Now let's see geometrically if it's gonna work. Now we are going to complete this parallelogram. I'm just sketching here, but if you use measurements, I'm sure it'll be more accurate. And this one I replicate it here, right? So where will the resultant be? The resultant will be from this side to this side, right? So the resultant will be here. Now look at the resultant. The resultant is closer to this stronger force compared to this weaker force. So you see, these geometric rules of parallelogram rule always will give good results, and they always work in resolving forces. You want to know why they work in terms of physics? Also, look my next video.